welcome back to the third and final video of Test 1, Spring 2018. Problem number 13 is a tricky one. We're looking at the freezing point depression of a variety of different solutions. So, freezing point depression equation is made up of 3 parts. Part 1, the freezing point depression constant, which is a constant for a given solvent that will not change. Part 2, the molality. Greater molality will result in a greater freezing point depression. The third and final factor is what's called the Van 't Hoff factor, factor I. So looking at these 3 solutions, which one of them will contribute to make the greatest freezing point? Well, they're all in the same solvent, so that won't change. They have the same molality, so that won't change. The only thing that could have effect is the Van 't Hoff factor. So I. Now, all these solutions are organic in nature. There's just carbon, there's hydrogen, and oxygen. With that in mind, these organic compounds will not break down in water, and so they will all have an I of 1. So with that in mind, all of these solutions will have the same freezing point, or answer D. Problem number 14. What is the molecular formula of nickel arsenide? Well, nickel arsenide, this is not quite a usual compound, so it's kind of hard to use the charge to cheat. So with that in mind, we have to look at the structure, use that as our way of determining what is the molecular formula. Looking at the nickel, there's nickels in all 8 corners and in 4 of the 12 edges. So all 8 corners, each corner contributes 1/8. So there's 1 nickel. 4 edges, each edge is a 4th cell. So each of the 4 edges adds up to 1 whole atom, so there are 2 nickels. Looking at arsenic, it's kind of hard to tell where arsenic is, but if you look at the lines and how the line from the bottom 2 left corners and the middle 2 left edges, are drawn to that atom has to be fully in the cell. The same thing for the other atom. There's always going to be symmetry in these structures. It's drawn to the cell. So there are 2 arsenics fully in the cell. So we have 2 nickels and 2 arsenics, meaning a 2-to-2 ratio can be simplified to a 1-to-1 ratio. And we have a structure of NiAs. Our final problem that we will discuss today is problem 15. Which of the following actions would decrease the solubility of a gas? So we have increasing the pressure of a gas, increasing the temperature of a gas, increasing the volume of a liquid, or none of the above. We've got to think about what happens to a gas when we do these actions. The solubility is controlled by kinetic energy opposing intermolecular forces. When we increase the pressure on a gas, it will push the gas into solution. So that will increase the solubility. This only has an effect on gases. Pressure increase will not change solid solubility, will not change liquid solubility because they are not really compressible, but a gas is. Increasing the temperature of a gas will give it more kinetic energy. Now for a solid and a liquid, this will increase the solubility on most situations, because greater kinetic energy will allow for the easier breaking of solute-solute and solvent-solvent intermolecular forces. Gases do not have these forces to break because they are individual atoms and molecules. So increased kinetic energy will give them more kinetic energy to escape from solution. So this is the correct answer B. Let's just go through C real quick. Increasing the volume of the liquid. Remember, solubility is a constant at a constant volume and temperature. So if you increase the volume, more things can dissolve in that volume. So increasing volume will increase the solubility. So once again, correct answer is B. Now, as I said, if you're in my class, this is not all the questions that would be on these chapters, but this is a good portion of them. So use this as a way to look at problems given for a given chapter. You have things such as parts per mass, percent mass. You have things such as molality, mole fraction. You have boiling point elevation, freezing point depression, vapor pressure. We have osmotic pressure. We have all these intermolecular forces. We have solids. We have looking at property of the solids and unit cells. All these things are more than likely going to be on some sort of test. Hopefully this will be helpful review. Thank you and goodbye.